Let's talk about how to solve a system of equation using all we've learned about inverses. So anytime you get to an example where in the instructions it says using an inverse matrix, you should know that the very first step is to write out your three different matrices. You have your coefficient matrix, so in this case would be 3, 8, 4, 11. We have our variable matrix, which is going to be x and y. And we have our constant matrix, which is 5, 7. So anytime you see those words using an inverse matrix, that's your first step. Step 1, rewrite them using your three different matrices. Now, for step 2, we need to figure out what the inverse of this matrix is. Let me rewrite it so we can see what's going on here. Excuse me. So we need to find the inverse of this matrix so I can multiply by that inverse and these will cancel out. That's the goal. Then I can just take that same matrix, multiply it on this side by the constant matrix, and then these will cancel and I'll end up with my variable matrix, and I just do some matrix multiplication over here, and that will actually be our answers. We're solved. We're done. So the only tricky part is actually finding what this inverse matrix is. So we're going to come over here, 2 by 2 inverse matrix. And I'm going to have you pause the video to find this. We've practiced this so far this lesson. You can either use, because it's a 2 by 2, you can use our inverse shortcut, use the equation that you can memorize, or you can put it side by side with the identity matrix, get it to flip over. You should get the same answer either way. But pause the video, use either method, come up with our 2 by 2 inverse matrix for this problem, and then we'll come back and solve the system together. Let's see what you got. I did both methods, so whichever method you use, you should be able to check your answer. But whether you use the 2 by 2 shortcut or you actually just put the identity matrix and get it to flip, you should end up with this matrix, which I copied into both of our places. Now, because these two matrices are inverses, we know that they're going to cancel each other out. And on this side, all I need to do is some basic matrix multiplication, and I have my answers. Now, one thing that is important to note, remember that we learned in 6.4 that the way you multiply matrices matters. Meaning, if I do this multiplication versus this multiplication, that matters. They're different answers. You can't flip matrix multiplication and get the same answer. So it is very important to note that this is not the way to do it. We put the inverse matrix in front here, so we need to put the inverse matrix in front here. They have to go in that same order. So you always do inverse matrix times constant matrix, always. So now that we've cleared that up, let's do some matrix multiplication. We always do this first row times this column, and then that row times that column. So I've got 11 times 5 plus negative 8 times 7. That one times that one plus that one times that one. And then move on to the next row. Negative 4 times 5 plus 3 times 7. And I simplify that down. This becomes 55 minus 56, which is negative 1. This becomes negative 20 plus 21, which is a positive 1, which means those are my solutions. X equals negative 1 and y equals 1. So I can write my coordinate point as negative 1, comma 1. And using our vocabulary, we know that this is a consistent, independent system because it has a single solution. So that is how we actually solve a system of equations using an inverse matrix. Honestly, the hardest part is finding the inverse matrix. Once you know that, you can multiply it on this side, cancel them out, multiply it on that side, and it's just some simple matrix multiplication, and you get your answers. So with that, we've done a 2 by 2. Let's go to the next page and try a 3 by 3. So first thing we notice in the instructions, using an inverse matrix, so we need to write out our 3 matrices first. I would like you to pause the video and try this on your own. Write our coefficient matrix, our variable matrix, and our constant matrix. And then come back to check and make sure you wrote those correctly. Let's see how you did. There's my coefficient matrix, my variable matrix, and my constant matrix. Now I rewrote it down here just like we did in the last problem, where all we need is this inverse matrix right here, and then those will cancel out. Remember that order is important. The inverse matrix goes first on the other side. Inverse times constant, always. So we just need to figure out what the inverse matrix is. Those will cancel. We multiply those together with matrix multiplication, and we got ourselves some answers. Now, you might be thinking, oh no, this is a 3 by 3 inverse matrix again. However, if you're very careful, you'll notice we've already found the inverse of this matrix in the previous video. 2, 3, 1, 3, 3, 1, 2, 4, 1. Come up here. Hey, look at that. 2, 3, 1, 3, 3, 1, 2, 4, 1. So you have already found what the inverse of this matrix is in example 4. We just need to copy it down. So we're going to come down here and we're going to write that the inverse matrix we found from example 4 is -1, 1, 0, -1, 0, 1, and 6, -2, -3. So I can write that in here. And in here. Those are going to cancel because they're inverses, and you just need to do matrix multiplication on that. Simplify it, and that should be your answers. Now, I'm going to have you pause the video and try this matrix multiplication out on your own. Remember the matrix multiplication pattern. We get row times column, and then repeated. So pause the video, try to solve this out on your own at this point, and then come back to check your final answers and see how you did. Let's check your work. Here's my matrix multiplication. I ended up with -2, 1, and 5, which I wrote as my coordinate point. Once again, consistent independent because we have a single answer. Now that you've practiced this a little bit more, I would like you to try example 7 on your own. So write out our 3 matrices. You will notice that once again, you'll have the same constant matrix, 2, 3, 1, 3, 3, 1, 2, 4, 1, same as up here. So you can still use the same inverse matrix. You just have a new constant matrix this time. That one's different. So that will change your answers a little bit. So use the process we just went through and try to solve example 7 all on your own. Let's check your work and see how you did. There's my 3 matrices. I knew I had to do that because it says using an inverse matrix. As soon as you read those words, that's what you know you have to do. And once again, same constant matrix, so I've already found the inverse for that matrix. I wrote it in, they canceled. I wrote it in front of my constant matrix. It's always inverse times constant. Did some simple matrix multiplication and found those as my answers. So that is all for solving systems of equations using inverses. Like I said before, really not that hard as long as you know what the inverse is. Finding the inverse is the hardest part. After that, it's just some matrix multiplication and you're good to go. So that is all for 6.5. You should be good to start on your homework now and good on inverse matrices. We only have one more lesson, one more method of solving systems, which is 6.6, and then we have 6.7, which is applying everything we learned to a type of story problem. And then we're done with chapter 6. Good job, guys.